Hey guys, today we're starting a new chapter, chapter 4. We are going to start with section 1, interpretation of the derivative in context. There is a lot of writing in this particular section, um, and instead of taking the time for you to watch me write, which leads to longer times on the video, I've gone ahead and filled out the notes. So you are going to need to make sure that you pause the video and get the notes for each of the examples that we see here. So everything that you are going to be doing is going to be based on writing about a problem. So Sean is cleaning out his saltwater fish tank and he needs to drain some of the water in order to adjust the saline levels. If the volume of the tank V is in gallons and it's being drained over time T in minutes, then what is a meaningful interpretation of the following statement as it relates to Sean's fish tank? So what this interpretation says is the derivative of the volume, the change in the volume with respect to time at time equals 3 minutes has a value of -2. So mathematically what that means is your derivative is a slope, and it's a slope of your tangent line. So V prime, your volume prime, your slope of your volume, of 3 equals -2. What this means, the rate is negative, first of all, because you're draining the fish tank. And then after 3 minutes, the fish tank is being drained at the instantaneous rate of 2 gallons per minute. So after 3 minutes, the fish tank is being drained at a rate of 2 gallons per minute. If that was positive, we would be filling it up. Again, pause your video to make sure you get your notes. Example 2A. The Alberta tar sands are one of the biggest oil reserves in the world, yet extracting the fossil fuel costs more than the profits made. If the cost C in dollars to extract a barrel of oil is losing $3 on every barrel, write the derivative. So we know that the rate is -$3 per barrel. So we just established our variables. C is our cost equals F of B, which is our barrel. So the derivative of that, F prime of B, is the change in C, change in cost over the change of the number of barrels, which is -$3 per barrel. That's the rate at which they're losing money. Part B, the Deepwater Horizon oil spill is regarded as one of the largest environmental disasters in American history. The oil leak was discovered on April 22nd, 2010. BP originally estimated that the flow rate was about 790 cubic meters per day at the end of the first week. Volume is F of T, time is in days. So F prime of 7 is the change in the volume over the change in time when time is 7, which is 790 meters cubed per day. Notice that um, we're not solving anything. We're just setting up the problem as it gives us the information um, in the words. Part C, the population P of the endangered mountain gorilla has an ongoing study tracking the number of gorillas since 92. Population increased by 114 gorillas during 2003 of the same study. That is a difference of 11 years. So P equals F of T, where P is your gorilla population, T is your time in years. So F prime of 11, the change in the population over the change in time when time is 11, is 114 gorillas per year. Example 3. Suppose a planet is discovered in 2024 and is named Newtonia. If the alien population P of T is recorded in millions of aliens and T represents the number of years since the planet's discovery, explain the meaning of each of the statements below. So this is asking for P prime of 3 equals 0.5. So we've got a prime, which means we have to establish a rate. The value here is positive, so that means we're going to be increasing. Here is our time. So in time equals 3 years, which would be the year 2027, the population of Newtonia will be increasing at a rate of 500,000 aliens per year. 0.5 times a million, 500,000. Now in part B, we're looking for an inverse. So we switch things around. The population on Newtonia will be 7.5 million aliens 5 years after 2024 or 2029. And then the inverse derivative, When the population on Newtonia is 7.5 million aliens, it takes 3/4 of a year for the population to increase by 1 million aliens. We've done several of those where you have to interpret the mathematical setup. What does it mean in words? And that's just another one of those. For example, 4, suppose you launch a water balloon from a giant slingshot. Let S of t give the distance in feet that the water balloon traveled from its initial starting point as a function of time t in seconds. Explain the meaning of the derivative notation. So what we have here is d of s over d of t, change in s over change in t when t equals 2, same as s prime of 2 is 38 feet per second. So that's what is given. In words, what does it mean? When time is 2 seconds, the water balloon is moving at an instantaneous velocity of 38 feet per second. Remember that s of t is your position function, and v of t, which is s prime, is your velocity function. I've tried to write as much stuff down here that I would say anyway, so that you have everything that you need. Example 5, the total cost C in dollars of an airplane flight is a function of the number of passengers in that can be calculated by derivative airlines using the function C equals F of N. What does it mean to say F prime of 182 equals 58? Well, F prime of 182 is going to be the same as C prime of 182. So C prime of 182 equals 58 means when there are 182 passengers on a flight, the cost per person for the flight is increasing at a rate of $58. Again, that positive value indicates that your rate is increasing. And number 6 is very much like number 3, where you just write out what the notation means based on a scenario. Non-potable water is being pumped into a processing center where the depth in feet of the water at time t in hours is given as y equals h of t. Interpret the following statements using the proper units. H of 7 equals 5. No derivative, no inverse, just simply means the non-potable water is 5 feet deep after 7 hours. Putting a prime in there and a positive means we have a rate that is increasing. The depth of the water is increasing at a rate of 0.6 feet per hour at time 7 hours. Your rate is going to be on the other side of the equals. What you have subbed in will be beside your variable. We have an inverse, so remember to switch things around. Instead of your time being here, your time is here. After 9 hours, the non-potable water at the processing feet is 7 feet deep. So inverse, A and C are inverses, so you just take the units and switch them. And then we have an inverse derivative. When the depth of the water is at 7 feet, it takes 1.4 hours for the depth to increase 1 more foot. All right, guys, that concludes section 1. Please make sure that you have paused your video accordingly and that you have gotten all of your notes. As we progress through chapter 4, you are going to find that this information and being able to interpret the information in the problem is extremely, extremely important. So even though there wasn't a lot of what I will call math in this particular section, there is a lot of writing, and it is very important that you get it all down. As always, if you have questions, let me know. Have a great day.